Hey guys, welcome back to my YouTube channel MedEdophilia, and in today's video we will continue with the last part of the chapter, some basic concepts of chemistry. So this part is extremely important because this part will be repeated in your next year in the chapter called Solutions of class 12. So pay attention to every point I tell you here so that your next year will be easy and so that you can relax and stay calm when you do your next year. Alright, so we are going to be looking at reactions in solutions. So the very term solution, especially when we say binary solution, it is made up of two components. One the solute and the other the solvent. So a solution is made up of two components. A binary solution is made up of two components, a solvent and a solute. Solute is the one which is present in smaller amount and solvent is the one that's present in larger amount, and it is the solvent that has the same phase as that of the resulting solution. So hence we can say that the solvent decides the phase of the resulting solution. For example, I take salt and water. Okay, salt is the solute and water is the solvent, and when you mix it to form salt solution, the resulting salt solution is liquid, same as that of water, which is the solvent, which is also a liquid. So here the solvent is deciding the phase of the resulting solution. Okay, what are the concentration terms which is involved in a solution? The very first term is mass percent weight percentage. Okay, we denote it as W by W percentage. Simple, which we've already learned. It is weight of the solute by weight of the solution into 100 because it's percentage. Next, mole fraction is denoted by X. Okay, that's the symbol. So we consider say two components A and B, where A is the solute. So we can write the mole fraction of A component, that is XA, is equal to Na by Na plus Nb. The very term mole fraction means we say the mole fraction, the fraction of the number of moles of A divided by the total number of moles. So number of moles of A by number of moles of A plus number of moles of B gives us the mole fraction of A. Similarly, mole fraction of B, Xb is equal to Nb by Na plus Nb. So here you need to remember one important point, that is the sum of the mole fractions of the components present in the solution is always equal to 1. So once we know one component's mole fraction, the other component's mole fraction can be found out by simply subtracting the value from 1. Next concentration term is molarity. Molarity is the most widely used concentration term, and molarity is defined as the number of moles of solute by the total volume of solution in liters. So if volume is present in ml, we simply have to multiply by 1000 because we have to convert it into the SI unit. The unit of molarity is denoted by capital M, which is molar, and 1 molar is nothing but 1 mole by 1 liter. So molar is nothing but moles per liter. So here you need to remember that molarity is temperature dependent. So this is important and a repeated question. Why is it temperature dependent? Because liquids expand on heating. We know that as we increase the temperature, the volume of the liquid increases. So here in molarity we have volume in the denominator. So this volume is varying with temperature. So what happens when we increase temperature? Volume increases, so molarity decreases. Temperature increases, molarity increases. So remember, molarity is is that one concentration term which is dependent on temperature. So whichever quantity has volume involved in it, that will be dependent on temperature. Next we have the concentration term molality. Molality, note the spelling. And molality is nothing but number of moles of solute by weight of the solvent in kg. Remember, it's weight of the solvent, not the entire solution. So you need to remember that. Whereas in molarity, it was volume of the entire solution. Same way, if this weight is present in grams, we simply need to multiply 1000. So since we saw molarity and molality, here's the time to discuss about the dilution law. So what the dilution law states that is, whenever you dilute or concentrate a solution, the number of moles of solute remains the same. So the numerator n remains the same. So M1 V1 cross multiply M1 V1 is equal to M2 V2 is equal to a constant. So since number of moles remains the same, it is a constant even after dilution, M1 V1 is equal to M2 V2 is equal to a constant, which is the number of moles. So this becomes our dilution law. So now let's discuss some formulae, some important shortcuts that you need to remember so that you can crack the question under a minute. So this becomes the challenging part in physical chemistry, this part, and this is the most important. So different quantities will be given in the question and some other quantity will be asked. So if you know formulae relating, direct formulae relating those quantity, you can just simply apply that formula and get your answer in just one step. Otherwise you'll have to sit and derive the relations based on the theory and simple basic formulae that you've learned before. So now let's look at the shortcuts one by one. What is the relation between weight by volume percentage and weight by weight percentage? How will you convert? We know weight by weight percentage. We know the definition which we've already seen. So what is weight by volume percentage then? Weight by volume percentage is nothing but weight of the solute by volume of the solution into 100. So always remember the denominator is always the quantity relating to the solution except that of molality. There it is weight of the solvent in kgs. Remember that. So the relation between W by V percent and W by W percent is W by V percent is equal to W by W percentage into density of the solution. This we got by the simple relation, that is density is equal to mass by volume. So from that we can derive this relation, because in the left hand side in the denominator we have volume and the right hand side we have the denominator weight. So simply we need to multiply it by the density of the solution in order to derive the relation between them. Alright. Now let's look at the relation between molality and mole fraction, small m and x. So m is equal to xa by xb into 1000 by molar mass, molecular mass of B, the solute, the solvent. So here you can remember, since I told you whenever there is molality involved, the denominator is always of the solvent and not of the entire solution. So that way you can remember that this is the molecular mass of the solvent and not of the solute or solution. Alright. So m is equal to xa by xb into 1000 by molecular mass of solvent. So once you know xa, usually only one mole fraction will be given in the question, either of the solute or the solvent. From that you can derive the other one by simply subtracting it from 1. So xb is equal to 1 minus xa and xa is equal to 1 minus xb. Simple. Now let's look at the relation between molarity and weight by weight percentage. capital M molarity is equal to weight by weight percentage into density of the solution into 10 by molecular mass of component A, that is the solute. So remember, here it is the molecular mass of solute, whereas in molality, relation between molality and mole fraction, it was the denominator had molecular mass of component B, the solvent. So remember that difference. So here in this formula you can observe that W by W percent into density of the solution, that itself is a formula of W by V percentage, the very first formula we saw. Yes, so you can write this relation as capital M is equal to W by V percentage into 10 by molecular mass of solute. So remember this. Next shortcut, finding the relation between molarity and molality. So molality is equal to 1000 into molarity by 1000 into density of solution minus M into, that is M is molarity into molecular mass of solute. So M, small m is equal to 1000 M by 1000 D minus M into MMA. Okay. Next trick, relation between weight by weight percentage and molality. So molality is equal to W by W percentage, weight by weight percentage, divided by molecular mass of A, the solute. Here it is molecular mass of solute into 1000 by 100 minus weight by weight percentage. So remember, weight by weight percentage is a percent, right? So it is definitely number less than 100. So here we subtracted, percentage itself means 100. So you can remember the denominator as 100 minus weight by weight percentage. So that way things will become easier for you. So these are some of the basic laws, the basic shortcuts that you need to remember. Along with that, we had the dilution law, that is, which had the principle that number of moles of solute remains the same even after dilution, as only the amount of solvent is getting changed. So let's quickly recap what are the shortcuts we learned. First one, the relation between weight by volume and weight by weight percentage. W by V percentage, repeat quick after me so that you can learn now itself. W by V percentage is equal to W by W percentage into density of solution. Second, dilution law, M1 V1 is equal to M2 V2. Third, M is equal to, small m is equal to XA by XB into 1000 by MMB. Next, fourth, capital M molarity is equal to W by V percentage into 10 by MMA. Next, fifth shortcut, small m molality is equal to 1000 M by 1000 D minus M into MMA. Next relation, sixth, small m molality is equal to W by W percentage by MMA into 1000 by 100 minus W by W percentage. So this, trust me, it's going to make your life much simpler, because this is going to repeat in your 12th standard as well. So make sure to learn these formula so that you can solve the questions in a very less time. So initially this is going to take some time for you to memorize, write and practice, but definitely you will thank me later, because this is extremely helpful. Now let's get into solving questions. Question solving for this topic is important, because here I will take up questions, those questions in which you will get stuck when you do it alone. So I will be covering those types of questions. I will not be doing the questions which is simple, just direct formula application, like volume will be given, probably the weight of the substance will be given, from which you have to calculate the number of moles, and then they will ask you to find the molarity. So simple based on N by V into 1000. I'm not going to do questions based on that direct formula based. Okay, I'm not going to do such questions. I will do questions which are little not straightforward, and in which you have to think a little bit. It might have two or three steps, two or three formulae involved in it. So I will be covering those types of questions. So firstly, the question is, if density of methanol is 0.793 kg per liter, so they've given the density of methanol, what is the volume needed for making 2.5 liters of its 0.25 molar solution? So this is the question. So density is given, volume 2.5 liters is given, and molarity is given. So V1 and M1, okay, is what we don't know. From the formula M1 V1 is equal to M2 V2. M2 is given, V2 is also given, that is 0.25 and 2.5. Let's assume that V1, the first volume, that is what is being asked. They are asking what is the volume needed for making. So they are asking another volume. So let's say that is X. So here in this equation, what is missing? M1 is missing. So that is what we have to find now. So you might ask me, how did I first jump on to this formula? How did we come to know that we have to use this formula M1 V1 is equal to M2 V2? Simple. Because see, in the question, some volume is given and some molarity is given, right? And the question demands us to find another volume. So from here we can understand that there are two volumes involved. So you simply have to think which formula had two volumes, that is V1 and V2 involved. From that we find that the formula, that is the law of dilution, M1 V1 is equal to M2 V2, that is the formula we need to use in this question. Okay, so moving on, they have given the density 0.793 kg per liter. So what does that mean? 0.793 kg of methanol has a volume of 1 liter. So they've given methanol. So let's calculate the molar mass of methanol. CH3OH, all alcohol with one carbon. Okay, so 12 plus 4, because 4 hydrogen plus 16 is equal to, we get 32 grams. So now is the time to find the molarity. So from here we can find molarity, because we need M1 here. So what's the formula of molarity? N by V. So number of moles given mass by molecular mass. So 0.793 given mass, because we are considering the volume as 1 liter. From density we know 0.793 kg is present in 1 liter. So 0.793 is the given mass by 32 was the molar mass, but grams. So be very careful with the units. So this is where units plays a major role. So you should multiply it with 10 power minus 3. We are converting grams to kgs. So into 10 power minus 3. So by volume, which is 1 liter. So that gives us 793 by 32, which is 24.78125, which is the answer, molar. Alright. So here we know M1, we need to find V1, we have M2 and V2. So simply just apply the formula. 24.78125 x is equal to 0.25 into 2.5. So x is equal to, we get 0.02522 liters. So converting it into milliliters, ml, approximating, we get 25.2 ml as the final answer. Okay, so this was the method. Let's move on to the next question. Calculate the molarity of a solution containing 20.7 gram of K2CO3 dissolved in 500 ml of solution. So they have given density of solution is 1 gram per ml. Okay. So read the question again. We have to find the molality. we have to find molality. They have given mass 20.7. Okay, and they have given the volume of solution. All right, so from mass we can find number of moles. They've given volume, so number of moles by volume is what? Molarity. So from here we can use the relation between molarity and molality. So here our short trick plays an important role. With this one formula, the entire problem gets solved, and even the density of solution is given in the question. So what is the formula relating the capital M and small m? So small m is equal to 1000 m by 1000 d minus m into mm of solute. This is what we learnt, isn't it? Recollect. Now let's find the molarity. What is m? Capital M, number of moles by volume. So for that, first finding number of moles. Given mass 20.7 by, what is the molecular mass of potassium carbonate? 2 into 39 plus 12 plus 48 is equal to 138. So 20.7 by 138 divided by the volume. Volume they have given 500 ml of solution. So since it's in ml, remember to multiply 1000 in the numerator. So solving, what do we get? 0.15 into 2, which is 0.3 as the answer. So we have molarity, we have density of solution given, we found the molar mass of potassium carbonate, which is the solute, everything is here. So simple formula substitution. So m is equal to 1000 into 0.3 minus but divided by 1000 into 1 minus 0.3 into 138 molar mass. So 300 divided by 1000 minus 41.4. Alright. So what do we get molality? The final answer, we get solvental 0.313 molal. MOLAL. That's the final answer. So did you find how simple the entire question became? You didn't have to do the long method. So there is also an alternate method which is long. If in case you forget the formula, the shortcut, if you find it difficult to remember, you should follow the long method. Let's see how this alternate method, the actual conventional procedure goes like. So first they've asked molality, that's the question. So first, what's the formula of molality? Number of moles by weight of solvent in grams into 1000, isn't it? So first step is finding the number of moles of solute. Since they have given the mass of the solute in question, it's easy to find the number of moles. Same here also we get 0.15. Now they have given density. So for doing the alternate method, you should derive data from you should derive information from all the data they have provided in the question. So first thing, they gave mass, so from that we found out the number of moles. Second thing, they have given the density. So what is density? 1 gram per ml, which is mass by volume. So they have given the volume, so we can find the mass from this density formula. So 1 is equal to m by 500, and mass of the solution is 500 grams. Remember, it is solution because we used because in the question they gave volume of the solution is 500 ml. So from this density formula we can find out the mass of the solution. So now is the time to find the mass of the solvent. What do we need in molality formula? There is weight of solvent and not weight of solution, remember. So we need to find weight of solvent. What is weight of solvent? Mass of solution, the total mass, minus the mass of the solute. So 500 grams minus 20.7, which they have given in the question. So which is 479.3 grams. That's the mass of solvent. So we have mass of solvent Okay, we have n, that is number of moles of solute. So simply you can substitute this in the equation and you can proceed. So here the numbers are simple, so it's not very difficult to find the calculation. So this method is also easier. So 0.15 by 479.3 into 1000, which gives us same 0.313 molar as the final answer. So I feel for other questions, this conventional method is quite long. It's a longer method. So I advise you to follow the first method because it's easier to solve in majority of the questions. Okay. So now we'll move on to the next question. Calculate the molarity of a solution of ethanol in water in which the mole fraction of ethanol is 0.04. So we need to find molarity from mole fraction. Okay, so first check if there is any direct formula relating both. So till now we only saw relation between molality and mole fraction. We didn't see how to find, there wasn't a formula relating molarity and mole fraction directly. So you should understand that this question is little different. You have to you have to extract information from the data they have provided in the question. So they have given mole fraction is 0.04. What is the formula of mole fraction? Number of moles of solute by the total number of moles of solute plus number of moles of solvent. So here ethanol in water, so it is an aqueous solution. We can understand from the question. And okay, so since ethanol is very less volume of the solvent, which is water, we can equate it to 1 liters. We can approximate. So we can neglect the volume of ethanol. So solute is ethanol and solvent is water, isn't it? So we know density of water is 1 gram per ml. I think this you all must have known. Density of water is 1 gram per ml. We know that. So from this data, even it won't be given in the question because it's something very general. You need to know it. It's common and I think most of you would have known it. So this will not be given in the question. So something you should know. Alright. So from the density of solvent, we find that we can write, since 1 gram has a volume 1 milliliters, we can say that 1000 ml is equal to 1000 grams for water. Okay. So from this we can find the number of moles of solvent. So why did we take 1000 ml? Because we are assuming the volume of the solvent, volume of water is 1 liter, because we have to find molarity. So what we are assuming, the volume is 1 liter, so that just by finding the number of moles we can find the molarity. What is molarity? The number of moles of solute dissolved in 1 liter of the solution. That is the definition. So in these places, the understanding the actual definition plays an important role. So what are we doing? This is an important point you should understand, and these are the conceptual questions that will be tested. So what are we doing? Ethanol is very less in water, so we are neglecting ethanol's volume. So we assume that volume of the entire solution itself is 1 liter. So the volume of solvent is 1 liter. Okay. So we have to find the weight of the solvent present in that 1 liter. Since it's water, 1 liter is nothing but 1000 ml. Since it's water, 1000 ml has a mass of 1000 grams, because the density is given. Density we know is 1 gram per ml. So from this we can find the number of moles of solvent, which is 1000 by 18 molar mass of water, given mass by molecular mass. 1000 by 18 gives us 55.55 moles. So this is the number of moles of solvent. So number of moles of solute present in 1 liter of solvent, 1 liter of solution gives us the molarity. So what do we need? We need to find the number of moles of solute in order to find the molarity, isn't it? So we found out that the number of moles of solvent is 55.55. So from this and from the mole fraction given, we can easily find the number of moles of solute. So equating that, 0.04 is equal to x. X is the number of moles of solute by x plus 55.55. So cross multiply, what do we get? 0.04x plus 2.22 is equal to x. So we get x as 2.22 by 0.96. What do we get? Calculate 2.31 as the answer. So molarity is nothing but number of moles of solute by volume of the solution in liters, which is 2.31 by 1 liter, because you assume that the volume of solution is equal to volume of the solvent by neglecting the volume of solute. So the final answer becomes 2.31 molar. So this is a conceptual question that you need to understand. Understanding the definition, understanding and deriving the information from questions, the data provided is important here. So I tried to cover up all the important and different models of questions that will help you to build your concepts instead of doing simple questions, simple direct formula based questions which anyone can do. So that was not my focus. My focus was to make you understand the different models of questions involved in this topic of concentration terms. Okay. So now we move on to the most important concept of the entire chemistry, I would say, which is equivalent mass, normality, the number of equivalents and all that. So first we see what is equivalent mass. So equivalent mass is nothing but molar mass by n factor. I'll tell you what n factor is. Okay, later. Okay. Next, what is equivalent volume? Molar volume. What is the value of molar volume? It is 22.4 liters by n factor. So equivalent mass, molar mass by n factor, equivalent volume 22.4 liters by n factor. Easy to remember. Now what is gram equivalent mass? Equivalent mass expressed in grams. So here you should connect and compare and learn equivalence and moles. Okay, number of equivalents and number of moles, you should connect them. Same like how we say gram molecular mass, it was molecular mass. Molar mass in expressed in grams was gram molecular mass. Similarly, equivalent mass expressed in grams is gram equivalent mass. Now I'll tell you what is n factor. Okay, n factor or basicity, or some people call it valence factor. Okay, n factor is nothing but acidity of base, which is number of OH minus ions produced by the base. So acidity of base means the number of OH minus ions produced by the base when dissolved in water. Say for example, you take magnesium hydroxide. It is a base, we all know. It dissociates into Mg plus 2 and 2 hydroxyl ions. So here the n factor of magnesium hydroxide is 2 because it's producing 2 hydroxyl ions when dissolved. So n factor of a base is nothing but its acidity, the number of OH minus ions produced by that base. When you define n factor of an acid, this is where the term basicity comes. So n factor is nothing but basicity of an acid. So Basicity of an acid means number of H plus ions produced by the acid. So base always produces H minus ions in water, and acid produces H plus ions in water. So let me give you an example. So for example, I take sulfuric acid, the king of all chemicals. What does it dissociate into? 2H plus ions and sulfate ion, SO4 2 minus. So since it's dissociating into 2H plus ions, the N factor of sulfuric acid is 2. So we saw what is meant by N factor for an acid, for a base. Now let's see what does the term N factor or valence factor mean for a salt. N factor here means the total charge carried by that salt. Say for example, I give you this salt KCl dot MgCl2 dot 6H2O. Okay, this is the salt. Now, what is the N factor of this salt? So, KCl has a valency 1 and MgCl2 has valency 2. So, the total charge is 3. So, this 3 becomes the N factor or valency factor of the given salt. So, in short, N factor is the number of replaceable hydrogen atoms, the number of OH groups present. So, this definition for N factor is useful particularly for oxyacids. Okay, so see, I am repeating, for different substances, acids, bases, salts, we are defining N factor in a different way. So keep that in mind. Okay, so let's take the oxyacids of phosphorus. First acid H3PO4, phosphoric acid H3PO3, phosphorus acid H3PO2, hypophosphorus acid. So H3PO4 phosphoric acid, H3PO or orthophosphoric acid also we say. Similarly, H3PO3 is phosphorus acid, or we also say phosphonic acid. Okay, and H3PO2 is hypophosphorus acid or phosphinic acid. So be very careful with the spellings and the pronunciation. Likewise, the formula also changes. So keep that in mind. More about oxyacids of phosphorus you will learn in P block of class 15, class 12. Sorry, group 15. I meant. Okay. So H3PO4. Let's draw the structure. For any oxyacid of phosphorus, there is compulsory P double bond O present. So that is a trick you can remember for drawing the structure of oxyacid. So in all formulae you have, in all structures you have P double bond O present, and then the rest you have to place the OH groups based on the formula. So one oxygen is over in H3PO4. So remaining you have 3 oxygen, and you also have 3 hydrogen. So you, this will appear as 3 OH groups. So simple, place 3 OH groups. Next we move on to the structure of H3PO4, H3PO3. How to write the structure H3PO3? Already I told you there is one P double bond O present in all oxyacids of phosphorus. So next count the number of oxygens. 3 oxygen atoms. Already one is over in the double bond. So 2 oxygen atoms. And but there is 3 hydrogen atoms. So this oxygen atom is present as OH ions. So 2 OH and 1 H. It is present as single bond H. Next, coming to H3PO2. One oxygen is present as double bond. So one so only one OH group will be present. So there are 3 hydrogen atoms, so out of which one hydrogen atom is used in OH group. So 2 pH bonds are present. So this is how you can draw the structure when you know the formula. Okay, so this here I have covered even structures of phosphorus acid, oxyacids of phosphorus. So this is going to be an important useful trick which you can remember for a grade 12, which will help you draw structures when structures become important. Okay, so from here I told you how to find n factor from the structure. N factor is number of OH groups. This number of OH groups will tell you the number of replaceable hydrogen atoms. Okay, so first H3PO4, how many OH groups are present? 3 OH groups. So what is the n factor? 3. Look at the second one. How many OH groups? 2 OH groups. So n factor is 2. For the third one, H3PO2, 1 OH group. So what is the n factor? 1. So when I ask you what is the n factor of H3PO4, what will you tell me? 3. So how to remember the n factors of different phosphoric acids? So here I will tell you a trick to remember in case if you don't know how to draw the structure. If you feel it's difficult, just by the without drawing the structure, just when they ask you what's the n factor of phosphoric acid, we know phosphoric acid is H3PO4. So simply H3PO4. So 4 minus 1, 3. Similarly H3PO3, 3 minus 1, 2. 2 is the n factor. Similarly, use the same trick. H3PO2, 2 minus 1, 1. 1 is the n factor. So did you get how to find the n factor just by the formula, just by looking at the formula, even without drawing the structure? This is how. So I hope now you would have understood how to find the n factor for different substances. Now let's move on to solve a question. Calculate the equivalent mass of NaOH, sodium hydroxide. So recollect what's the formula of equivalent mass? Given mass by n factor. So for molecular mass by n factor. What is the molar mass of NaOH? 40. So 40 by 1. N factor of NaOH is 1 because NaOH dissociates into Na plus and OH minus. Only one OH minus. So n factor is 1. So the equivalent mass is 40 gram per equivalent. Next, calculate the equivalent mass of calcium hydroxide. Come on, fast. What is the formula of equivalent mass? Molecular mass by n factor. What is the molecular mass of calcium hydroxide? 40 plus 2 into 16 plus 1 by n factor is 2. So the answer is 37 gram per equivalent. Okay. Now let's discuss what is number of equivalents. So what was number of moles? What was the formula for number of moles? Given mass by molecular mass. So what will be the formula for number of equivalents? Simple. Given mass by equivalent mass. Simple. Instead of moles, you should replace equivalents. That's it. Now tell me number of equivalents. The relation between the number of equivalents and number of moles is this. Number of equivalents is equal to n factor into number of moles. This is the important relation that you need to understand. Now let's see what is normality. Like molarity, we have a term normality. So we know molarity is number of moles by volume. So what is normality? Number of equivalents by volume of solution. Simple, isn't it? So now what's the relation between normality and molarity? Now you tell me. Simple guess. Normality is equal to n factor times molarity. Simple, isn't it? Now I'll tell you. I'll give you a question. Okay. So here I will cover different models of questions. So pay attention to each and every type of question that I am giving you. Okay. The question is, equivalent mass of a metal sulfate is 100. Then the equivalent mass of its phosphate is. That's the question. Okay. So equivalent mass of, let's say the metal is M. Okay. So MsO4 is equivalent mass of the metal plus equivalent mass of sulfate. So in the question they have given equivalent mass of metal sulfate as 100. Now our job is to find the equivalent mass of metal and metal sulfate. From we can easily find equivalent mass of metal sulfate, and from that we can find equivalent mass of metal as well. Then once we know equivalent mass of metal, We can find the equivalent mass of its phosphate by simply adding it with the equivalent mass of phosphate. So let's see how. Let's do it slowly. First step, finding the equivalent mass of sulfate. What is the equivalent mass of sulfate? Given mass by n, molar mass by n factor. What is the molar mass of sulfate? 32 plus 4 times 16 by 2, because here we see it's a radical, acid radical, SO4 2 minus. So it's a part of a salt. So what did I tell you how to find the n factor? It's always the charge on top of the salt, isn't it? So total charge here is 2. So n factor is 2. Okay. So 96 by 2, 48. So 48 is the n factor of sulfate. Equivalent mass of sulfate. So equivalent mass of metal sulfate is 100. Equivalent mass of sulfate we found it's 48. So simple subtract. What is the equivalent mass of the metal? It is 100 minus 48, which is 52. So now what are they asking us? They are asking us to find the equivalent mass of its phosphate. Same way. What is the equivalent mass of phosphate? Equivalent mass of the metal plus equivalent mass of phosphate. I am splitting the terms. What am I doing? I am writing equivalent mass of the metal phosphate is equal to equivalent mass of the metal plus equivalent mass of phosphate. How to find equivalent mass of phosphate? Simple. Molar mass by n factor. Molar mass, tell me. 31. 31 is the atomic mass of phosphorus plus 4 times 16. Now tell me what's the n factor of phosphate? It is PO4 3 minus. So there is a minus 3 charge. So n factor is the total charge. So by 3. So 95 by 3. What do we get? 31.67. Okay. So now we can easily find the answer for this question. We have found out the equivalent mass of metal is 52. Yes. Now we have just found out that equivalent mass of phosphate is 31.67. So just add. What do we get? 83.67 as the answer. 83.67 gram per equivalent is the equivalent mass of that metal phosphate. Understood? Revise this again. And now watch the next question. So the next question. Okay. Find the n factor of FeSO4 dot NH4 twice SO4 dot 6H2O. So now tell me, grade 12 students, tell me, what is the common name of this chemical compound I have given you? Is it a double salt? Yes, it is a double salt. Tell me, in coordination compounds you would have learnt, what is the common name of this? Okay, it's there in your NCERT. Alright, so let's move on to finding the n factor. So what did I tell you? For such salts, we have to find the total charge. For FeSO4, just by looking at the charge present in the acid and base radical, it's Fe plus 2 and SO4 2 minus. So the charge of this is 2. Similarly, for NH4 twice SO4, the total charge is 2. So 2 plus 2, 4 is the n factor. That's the answer. So I'm just mixing up and giving you all the questions, okay, in random order, so that every time you see I'm not like doing same kinds of questions again, same topic questions. I'm doing different topic, different method, okay, so that each time you see that question you're going to recollect the formula. Okay, when you learn a concept and do a formula based on that, you will obviously remember the formula. But after leaving a gap, when you see a question from a different concept, that time you should know, you should be able to recollect the formula. Okay, now find this is a very different type of question. I'll tell you. Find the n factor from the following reactions. So this is an acid base reaction. First reaction, H2SO4 plus NH4OH giving rise to NH4 HSO4 plus H2O. Okay, so we know n factor of H2SO4 is 2. Look at the product side. It's NH4HSO4. So from H2SO4, it has become HSO4. So we find that one hydrogen is being replaced. So what did I tell you? N factor is equal to number of replaceable hydrogen ions. So N factor is 1. Understood? Next, I'll give you another question so that you understand this concept better. H3PO4. What is H3PO4's name, chemical name? Phosphoric acid or orthophosphoric acid plus NaOH, giving rise to Na2HPO4 plus 2H2O. Okay. So look at the acid component in the LHS. It's H3PO4. Quickly tell me what's the N factor of H3PO4? For the trick I told you, it's 4 minus 1, 3. 3 is the N factor of H3PO4. Alright. Now look at Na2HPO4. We find that there's one H. So what is the number of hydrogen atoms replaced? 3 minus 1, which is 2. So the answer for this question, the N factor in this reaction is 2. Understood? Now you are able to understand what do we mean by the number of hydrogen replaced. We have to compare the N factor in reactants and product and then subtract to find the N factor. Okay. Now here I give you an important tip, an important data. So for you to remember for easy calculation. So here there are 3 columns. The element, the equivalent mass, the equivalent volume. This data you need to remember so that you can be quick in your calculations. So for 3 elements you need to know. First element, oxygen. Equivalent mass is 8. Equivalent volume is 5.6. How do we find the equivalent volume? What's the formula? Tell me. It's 22.4 liters by N factor. What's the formula of equivalent mass? Tell me quick. Molar mass by N factor. Yes. So here you can also sit and find the equivalent mass and equivalent volume, but I recommend you to remember so that your calculations become extremely fast. That's what I want because in physical chemistry fast calculations with accuracy matters a lot. Okay. Next element is chlorine. Remember, equivalent mass is 35.5 and equivalent volume is 11.2. Next, hydrogen. Take hydrogen. Equivalent mass is 1 and equivalent volume is 11.2. So remember, for chlorine and hydrogen, for H and Cl, equivalent volume is the same, 11.2, and for oxygen it is 5.6. Remember this table. Okay, now let's get back into question solving. Calculate the normality of the solution containing 31.5 gram of hydrated oxalic acid in 1250 ml of solution. So I gave you a question asking us to find normality, which we learnt initially, isn't it? Little early. So now try to recollect the formula of normality. Normality is number of equivalents by total volume of the solution. So here in the question they have given hydrated oxalic acid. So what substance is that? It's COH dot 2H2O. That is what hydrated oxalic acid means. So what's the formula of oxalic acid? Oxalic acid is a simple acid containing 2 COH groups. Okay, 2 carboxylic acid groups. So it's H2C2O4.2H2O. That's the chemical formula of hydrated oxalic acid. Now we have to find the normality. Before that we need to find the number of equivalents. Before that we need to find what's the formula of number of equivalents? Molecular mass divided by N factor. Before that we need to find N factor. What is the N factor? Yes, it's H. It's oxalic acid. So 2 H plus ions. Can you see 2 H plus ions? So N factor is 2. So molecular mass of oxalic acid is 126. You can calculate. It's 126 by 2. So the number of equivalents becomes 63. So from this easily we can find, sorry, this is the equivalent mass. So equivalent mass is molecular mass by n factor, which is 63. Okay. So now number of equivalents is given mass by equivalent mass. So the given mass is 31.5 grams, which is given, yes, and the equivalent mass which we have just found out, which is 63. So 31.5 by 63 gives us approximately 0.5. So normality we just found out number of equivalents, which is 0.5. By volume we have given 1250 in ml, so into 1000. So normality is 0.4 n. So that's the final answer. So understood? So shall we move on to the next concept of the class? Yes, it is law of chemical equivalence. So this law simply states that the number of equivalents of reactants is equal to number of equivalents of products. Say for example, I take this reaction. X molecules of A plus combines with Y molecules of B to yield Z molecules of C. So what does this mean? Weight of A divided by equivalent mass of A is equal to weight of B by equivalent mass of B is equal to weight of C by equivalent mass of C. So what is this weight by equivalent mass? It's nothing but number of equivalents. So what I'm trying to say is the number of equivalents of A is equal to number of equivalents of B is equal to number of equivalents of C. This is what the chemical law of equivalence says. So number of equivalents of each of the reactants is equal to that of the products. So hope you have understood the law of chemical equivalence. So I'll give you a question. Find the equivalent mass of metal if mass of metal and its oxide is X and Y. Okay. So we know how is a metal oxide formed. Metal combines with oxygen to form metal oxide. They have given mass of the metal is X and mass of metal oxide of its oxide means mass of the metal oxide is Y. So what will be the mass of oxygen? Y minus X, isn't it? So from this reaction we can say that the number of equivalents of M is equal to number of equivalents of O is equal to number of equivalents of Y of MO, sorry, metal oxide. So what is the formula of number of equivalents? Given mass by equivalent mass, isn't it? So given mass first for M, let's write. So X by equivalent mass of the metal is equal to Y minus X by 8. So we can easily find the equivalent mass of metal which is being asked in the question. Yes, which is 8x by Y minus X. So this becomes our final answer. So that's it. We have covered each and every topic of some basic concepts of chemistry, and there was a purpose for me to go little beyond NCRT because this concept is important, and this concept is important for you to understand other concepts of chemistry which you will be learning later also. So this forms the foundation. So equivalence, normality and everything, forms the base. This is something which you need to really know. So please do not skip this part thinking that it's outside NCRT. So it's important to have a knowledge on these concepts as well. So practice more and more questions on these topics so that you can master physical chemistry and the speed improves with accuracy. So thank you so much for watching. Hit the like button if you had found this video useful, and consider subscribing because it takes a lot of time and effort to make this video, gather concepts and collecting important questions, different models of questions. So stay tuned for more such useful videos and problem solving.